So we generate the tree, bond tree that is consistent with the interest rate tree. So, and then next, okay, let's add the code. So A is our observed bond price. So in case of 2 period, let me say this is 2. Then this one, this is our theoretical bond prices, but it is observed bond price. So what we wanna do is we want to find the first mu, first drift term, then make this one and this one same. In order to do that, we have to make a function that calculates difference between this one and this one. Okay, so in order to find the differences, of course, what we can do is basically it is the so here the difference is basically the difference is basically A0, the first element, minus oops, sorry, this one. So this one first, this one, the element of the, yeah, the element of the 1, 0, right? So this is the 0, 1, and 0. So this is this value. So gap is this one minus A0. So this is gap. And then usually we want to square it. And by squaring it, what we wanna do is to find the drift term that minimizes this one. And minimum, of course, when this term in the parenthesis, this one becomes 0, at which case A0 should be equal to this one. So basically, I'm looking for the drift term M, here mu, that makes minimize this one, which equates this one and this one. So what I have to do is I have to define error function, define bond error function. So bond error. Here, our initial input would be mu. We have a 2 input mu and then A, right? And then here mu. So what we have to do is first we have to generate interest rate tree, but then M is, of course, our initial M was mu was so here mu old, okay, mu old, M old equals basically 0, first term, and then we add mu. Let's define M old, and then add, right? Add our new mu, okay? Then 0 and mu, 0 mu, which we are interested in. Then given this mu, we want to calculate interest rate tree, RTR. Let's simply call RTR interest rate is we define interest rate tree over here, R tree. here, this is simply R3, R3, and then the input variable is mu. Okay. Actually, the name is M world. So let's make it M world, another M world, and simply update it and copy paste this one. And the other input R0 volatility dt, R0 volatility dt. Okay. And then given this interest rate tree, we have to generate bond tree, JCB, bond tree temp, let's say bond tree temp, which is find tree of the bond consistent with this one, RTR, and then DT, right? And then we wanna return. What we wanna return is this part, actually. So what we wanna return is G A0 here, A0 minus A0 minus, and then BTR. Actually, let's make it name same BTR, bond to BTR. Here, it is basically 1, 0. And then square of this one. Okay. It should generate the same one. So this is, let's say, this is gap 1. Let's print gap 2, which is should be now bond error, bond error, bond error, and then first one is 0. Okay, 0.3 because our new one was a 0.3, and then we have A, and then let's see. Gap is this is similar but not exactly same. So it seems that there is something wrong with my code. So where is it? Where is wrong with my code? A0 mu A0 here. So there is a mistake in my code. 0 PTR. Let me print mu. Let's clear. So second term is 0.003. So let me 0. Okay. Now we have the same one. Okay, yeah, same one. But again, as you know, this is not so general. Okay. And then we want to make it more general. Okay. So instead of this one, let's make it a function so that we make input m world as an input, m world as an input. Okay. And then this volatility and dt thing, let's make this one also input parameter. Okay. They are input. And then R0 volatility dt is simply param 0, parameter 1, and then parameter 2. And of course, it should not work. Make it more general. And then mu and a, because we already used this one. So let's make it this one general. So this is new one. And then therefore, gt is the same, mu a should be this one. And I have to add mu this pair. Okay. And then now instead of 0, 0, 3, and 8, they are fine, but I have to add parameters. Parameters such that R0, volatility, and DT, okay? And then M old, which is I start from 0, so 0, and then print 0 T. There is something wrong, so I have to think about the length. So M old, M old, M old. This one. Let me computing. So let's add a bar over here. So in order to distinguish it from the previous one. Previous one. And then what I can do is, let me batch. This is initial value. This is A0. Okay, and then this one, let me, this one has parameters, S, let me put S, and then params, okay, okay, parameters, R0, volatility, DT, this is correct, and then this is, let's say, this old, M old equals, let's say, 0, right? And then instead of this one, I can put old value. Okay, old value now is fine. Okay, but again, this 0, this is not general, so I want to make this one as t minus 1. So when t equal to, this one equals 0, and t equals let's say, length of m old. Okay, this is fine. And then actually, what I can do is I can move entire this one over here. Then because I didn't add over here, so it is +1 over here. Then I have the same one. Is there any way I can make this one more shorter? I think this code is short enough. So here basically, I created a function that calculates gap between our theoretical value here. Theoretical value is this one, and then this one, A1. So yeah, this is the just the manual value, and this is the I calculated from the function, so they look same. Okay, let me try the second one. T equal 2, t equal 3. Okay, here it looks like this, and then when we have 3, index 2 is out of bounds. So yes, of course, the interest rate over here is overbound. So here it is basically the 2, and this is the 1. And then here bond tree, we have here now 0, M old is 0, and then this one, old is this one. And then mu is, where was the view? So code over, and then view. So 0.005. So initial value 0.005, 0.005, and then what is wrong? 0.005. Yes, here now gap 2 is this one, 0.005, and then here 6 t equals 3, 2, 0, and then bond error, this one, and then t length. Okay, so here I am interested gap between this one, 2, 1, 0, 1 to 2, 0, this one, and then this one. So it should be not 0. It should be more general. So bond error is basically here t minus 2, right? If t equals 3, so yes, so they are exactly the same. So I created function that calculate very general function that calculated, that compute the errors between theoretical bond price and realized bond. The next step would be given these parameters and bond and parameter and previous one. Next step is to find the mu that minimize this error function to basically make this error 1 0. So that would be our final step. So which we will continue in the next video.